Hi students, welcome to Year 11 Chemistry and Module 3 on Reactive Chemistry. This is our last little section in Reactive Chemistry where we have a bit of a look at the factors that affect the rate of a chemical reaction. And in the first of these, we're going to look at temperature. In order to best understand what's happening in any chemical reaction, we need a little bit of an understanding of collision theory. We previously talked about the kinetic theory of matter, which is that matter is in constant motion. Kinetic theory equals matter in motion. So moving objects have kinetic energy, and therefore if as long as we're not at absolute zero, all matter, even the particles in a solid, are going to be vibrating, and therefore they're all moving. In collision theory, we expand our understanding of kinetic theory to say that because these objects are moving, they can actually run into one another. And when they run into one another, there may be sufficient energy for the bonds within the reactant particles to break. Depending on the circumstances, the breaking of those bonds can then just reform, or they can reform in a different way in order to form to one or more new combinations, that is, new products. So what we need then is to understand that for any reaction to occur, the reactant particles must collide with each other with a sufficient amount of energy to break the bonds within the reactants. If the circumstances of this collision are just right, then we may find that the two collide, form a new bond, and therefore we have a new substance. And if we have a new substance, then we have a chemical change or a chemical reaction. To understand the factors that affect this, we need to keep in mind not only the fact that the particles are in motion, but also the fact that they need to collide, and when they collide, they need a certain amount of energy in order to react. In fact, we're going to have a look at this in a little bit more detail later on, but we actually have a specific term that relates to the amount of energy needed for a reaction to occur, and this is known as the activation energy, or the energy of activation. It often has the symbol EA. To, I guess, explain this in a little bit more detail and put it into a context where we're aware of a reaction that is, I guess, common to most people will be the reaction between magnesium strips, magnesium solid, and oxygen gas. When the magnesium and the oxygen are reacting, you get this very bright flame, and you at the end get a white powdery substance, which is magnesium oxide. So this is two elements combining to form a compound, which we've said is an example of a synthesis reaction. In fact, if we put oxidation numbers up the top, because both magnesium and oxygen are in their elemental form, their oxidation number is 0. But in the compound, oxygen would be a -2 and the magnesium therefore a +2. And so what we've had is an oxidation reduction couple happening. So this is also an example of a redox reaction. Neither of those two are relevant specifically to what we're talking about, but it's useful to kind of keep going every time we look at examples to think about what they are examples of and what's going on there. What's most interesting about this reaction, though, is that when magnesium sits on the bench, it does get a very dark coating over the top of it. So we know that it's a fairly reactive metal and it is reacting, but it doesn't do that fantastic glowing reaction that we get unless we heat it up. When we add heat, that is, we increase the temperature, what we are doing is adding kinetic energy to the particles. And kinetic energy is equal to 1/2 mv squared. So that is, it's a function of mass and the square of velocity. So if we increase the heat, we increase the kinetic energy. We haven't changed the particles, so the mass is the same, but what we have done is we've increased the velocity. They're now moving faster. Because they're moving faster, they have more energy. They are more likely to have sufficient energy to reach the activation energy, that is the energy they need in order to react, and therefore we're more likely to have a reaction. So in most cases, what we find is increasing the temperature of a particular reaction will increase the rate of that reaction. We'll actually have a look at a specific example in class of where this occurs. And it's important for each of these examples that you look at some practical reactions to show how each of these factors can actually affect reaction rate. In the next couple of videos, we'll look at a couple of the other factors that are important in increasing the rate of a chemical reaction. Thanks for watching.